anything that's there. Essentially we're just trying to understand a bit more about the universe, why it's like it is, and what's going to happen in the future. So the way we do that is we have this 27-kilometre long tunnel underground, so it's about 100 metres under here. Accelerate protons in one direction and then in another direction, make them rotate a lot, very, very fast, hit each other, and where they collide, we build a big sort of digital camera around it and try and see what happens.
So we collide only protons?
Most of the time. At the moment, yes.
So, this is high school knowledge physics, right? But I always thought...
we're going to go in here.
Really?
Yeah.
So I always had this image that a proton is in an atom, right?
No. It's inside an atom.
Yes.
Yeah.
And so you have to peel that apart before you can hit the protons and make the protons collide.
Yeah.
So you peel the atom.
Which is very easy.
Really? You subtract the protons and you like filter them into the accelerator and then you make them collide? Or how does that happen?
So, you heard of hydrogen?
Yes.
So all hydrogen atoms, all they are, one proton and an electron.
Yes.
That's it.
So
if you have so we start actually with a small bottle of gas, a small bottle of hydrogen gas. It's about this big, and then that goes into a thing called an ionisation chamber, which just takes off the electron. You're left with a proton. There you go, easy.
And then you pump them into the
And then we put them in the accelerator, make them go faster, bash them into each other, and form chemical. It's actually really easy.
The proton is positive, right?
Yeah. Proton's positive.
You're trying to collide both positive charges. They're supposed to repel from each other.
Yeah, but
how do you make them?
They're traveling really fast.
They're traveling.
But don't they in the last minute like?
No. So they're traveling. So, you know the speed of light.
Yeah.
Is 300,000 kilometers per second.
Yeah.
The speed that they're going is 20 kilometers an hour less than that.
Oh.
So it's the speed of light.
So it's essentially the speed of light. And then you smash them into each other and see what happens.
So how do you accelerate?
Yeah. Electric field. So if you have a battery, just a normal standard battery like you've got in your telephone or something, it has a positive and a negative. So if you put an electron in there, or let's put a proton in there, it's attracted to the negative and repelled by the positive. So it gets faster.
Can we do the collisions at home?
But you've got...
You do, you used to. So when you had before the days of flat screen TVs, you had these old cathode ray tube TVs. That's a particle accelerator.
Really?
That was it.
It's an electron accelerator.
Yeah.
Oh.
So it accelerated electrons towards the screen and steered them using magnets. So if you've got a magnetic field here and an electron goes through, it will bend. Okay. And the same with a proton, but it will bend the other way because the charge is opposite. So the electrons coming from the TV were hitting the screen, defined by how you operate magnets. And then the detector, the thing that figured out what happened, is your eyes.
Yeah.
Because you figured out. Here, what we're doing is building a slightly bigger detector, or it's built now. We're going to go and see it.
Do you create energy by colliding
No,
protons?
you cannot create energy. You transform it from one form into
The
another.
protons have energy.
But do they, okay, let me correct myself. Do you accumulate energy
No.
into, like, in that particular collision when they hit each other?
No, they just break up into smaller pieces. But the protons, the two protons have a lot of energy.
Yeah. So, and
When
then
they collide-
they hit each other. What does happen then?
Well, then you get lots of other things produced with protons.
It's very warm, strong smell of coffee.
Well, yeah, is it,
As David said, you can't create energy.
But you release energy from the...
There is some potential energy within the proton.
So, I mean, the general things, the sort of physics that you need to know really to do a lot of what we do is really high school physics or even below. You remember something called conservation of energy, which just says you can't create energy, you can just turn it from one form into another. So if you make something go really fast, it has a lot of energy. So Paul runs when he's playing football, he doesn't have a lot of energy. The faster he runs, the more he has. If he smashes into someone, it's going to hurt.
Breaking it up.
Right? It's never happened before, is it? I know. So you just turn it from one form into another. There's the only equation you ever need to know is E equals mc squared, famous equation. E on one side is energy, on the other side is m for mass. So when you release this energy, you transform it into like pure energy, it can create new particles, new mass. And what we hope is that we create something like this Higgs particle that most people have heard of. Or something else, things we don't know. So that's the kind of process. So we collide, particles fly out in all directions. We have to look with a big digital camera at what happened and try and understand what happened in the initial collision. So what we're
is
going
at the same speed there? So the E equals mc.
No, it's not quite. C is the speed of light, you forget it.
That's just
Just a number. No, it's not quite as simple as that, but don't worry about that. So what we do here is one of the big detectors that looks at what happened. It's 100 metres underground. This time next week, you won't be able to visit it again, probably for the next 2 years. So you're quite lucky.
say thanks.
Thanks.
So what we've got here is, this is the main controller. When you're horribly disfigured after going underground, you don't blame us.
Do we have to like turn off the cell phones and things like that? I think we just got the like parked over.
There's Pinky. There's Brain. Slowly taking over the world. We're waiting to sign in, so I'm gonna hit pause for a minute.